Hello, welcome to this video. So in the last video, we made a mock-up, we made a chicken burger class to help us compute the cost of a chicken burger, like this. And now we actually filled the methods in using mock-up classes. So mock-up classes are just placeholders there. We are just classes there to give us simplified outputs, because like here, for example, petty cost, we'll use the mock class mock petty, and the mock petty has a method called cost, and all the idea of this petty is just to return us the cost of the patty, of the chicken patty. And the bun cost is bun's cost is just supposed to return us the cost of a bun. The other cost is supposed to return us the cost of other things. Okay. All right. So now let's code the so-called rail classes, which are a little bit more complex. Okay. Again, they may not be like so simple like in this video, but I'm just writing it so that we can have a demonstration. So let me just copy and paste this mock buns here. So I'll copy it and paste it here. So I'll just, instead of calling it mock buns, I'll call this buns. And the cost of the buns, okay, the cost of the buns is let's use a few methods to calculate the cost of a bun. Maybe you can have the cost of wheat cost. Okay, so double cost equals to how much? Maybe 20 cents. Okay, return cost. Okay, and then what else you have? Private double. Of course, we can have more complicated methods or more complicated ways of calculating the wheat. Then we have wheat process cost. So you need to process wheat into flour, and then you need to process flour into bread. So we'll just have that double cost equals maybe 80 cents. Okay, cost equals to 80 cents. And then I will return the cost. And then what else? We'll have transport costs. Okay, transport. We need to transport the wheat, the buns, eventual buns to the site. Maybe the transport cost is another 30 cents per bun. Of course, these are not realistic numbers. Right? At least I hope they don't become that expensive. But yeah. So the cost here, what will it be? Will be equals to the wheat cost plus process cost plus transport cost. Right? So this is the actual so-called actual buns cost. Of course, we can have these functions actually represent something more realistic for whatever reason, but that's what we have here: the wheat cost, the process cost, and the transport cost. Then we can do it for other things as well. We can do other CS and petty.cs as well. Then we'll use the okay. Actually, let me open all of them up. dimstar.cs, that will open everything up, and then I will use the vsplit. Okay, then I will go to the next file. The chicken burger file will be on the right. The other file will be on the left. So I will copy and paste this mock other. Okay, and then I will paste it here. Okay, I will use the other class. Okay, I'll make another class, private double. Okay, so for others, maybe I'll have pickle cost. Okay, pickles will cost maybe 30 cents. Return. Actually, I don't think pickles should cost that expensive. Maybe 4 cents or 2 cents a pickle. Okay, 0.02. Okay, what else do we have? We like to put barbecue sauce. BBQ sauce cost. Okay, and then open and close. And then double cost equals to 0.005, even less than 1 cent. What else do we have? Okay, we like to put tomatoes sometimes. Tomato cost 1 or 2 slices, that usually goes into burgers, equals to 0.03, maybe 3 cents a slice. Okay, so these are just examples. Then I'm going to say that my cost of all my other ingredients is pickle cost plus barbecue sauce cost plus tomato cost. Okay, hopefully no errors here. And I'm going to copy and paste all of this, and I'll go and put it into the patty file. Okay, patty is very similar to wheat in the sense that let me just change this. Instead of other, we will have patty. And the pickle cost, well, there's no pickle cost here. Let's call this farm cost. For rearing chickens in the farm, you need to pay maybe $1.20. Okay, and then I will replace this pickle thing by farm. CW farm cost. So what's next? We don't use barbecue sauce here. Well, we'll need to unfortunately slaughter the chicken. So the word used is process. Okay, process cost. I don't know, maybe you have to hire people or what. Maybe this will be more expensive, $3. Okay, so process cost. Okay, and the last one will be transport and storage. Maybe you just call it logistics. And then I'll just put down here another 140. So the last one will be logistics. Right, logistics. Okay, so this is maybe a more realistic way of calculating costs. So we have our petty class, which will maybe give us a more realistic number. Okay, it's not truly realistic. I didn't go and Google all these numbers up, but at least it shows you it's an improved version of the mock patty, because this thing just gives you $5. We didn't break down the cost over there. So how let's say we want to change the classes that we use. Okay, technically speaking, we'll need to open up chickenburger.cs again. Okay, on the right, and then we'll need to do this, right? Patty equals to new patty. All right, and then patty equals new patty. Sounds funny. It's almost like a nursery rhyme or something. I don't know. Okay, and then the buns class you'll need to change it from mock buns to buns, right? Buns. Okay, and the other class we'll need to change it to mock other equals to other equals other. Okay, here's the other class. So that's it. Now, okay, for if we have 3 or 5 classes, that means we'll need to change all of these things 3 or 5 times if we were to change from the mock thing to the real thing. Now, if we do it manually, you see that the cost now is slightly different. Yeah, we have successfully used I guess the more realistic version of the cost of other ingredients and patties and what else, and buns. So In fact, as long as the methods actually return have a cost, as long as the classes have a cost method, you can pretty much interchange the classes here in and out. Whether you want to use mock buns or you want to use class, as long as they have this cost method, yeah, everything should be fine. Okay, so I can even make a third class called buns complex. I can give you more complex ways of calculating the cost of a bun, and then I'll just substitute it in here. And this is how we normally change our chicken burger class so that it can reflect the new new dependencies here. Now, that's well and good for a very simple case. But let's say every time I change, I'm prone to, of course, there is a chance I can make a mistake inside this chickenburger.cs. So let me introduce and pretend that I made a typo somehow over here. Okay, buns equals new buns, and then I will just say buns equals new ns. All right. And of course, this is not the only place we can have typos. We can have typos all over the place. Every time we edit chicken burger, there is a chance that we can be introducing new bugs into the chicken burger class, and this will make our life kind of difficult. So you can see that it says the type or namespace name and s cannot be found. So this is the bug here. Okay, so I mean, every time we change the dependencies out, we swap the dependencies out, there's going to be a chance we are going to introduce new bugs into this chicken burger class. Ideally speaking, if we want to change the dependencies from, let's say, mock buns to another class called buns, we do not want to have this chance of what do you call that? Of introducing new bugs into the system, because we need to change code in chickenburger.cs. Okay, we'll be changing the chickenburger.cs, and then we'll be having a new chance of introducing bugs every time we need to change. So how can we avoid this problem? Because this is if you have a much more complex code, there'll be many more chances you're going to have typos. And when you have typos or other things, there's a lot more chances that you are going to mess up the chickenburger.cs file on the right hand side. Right? So here is the problem when we do it this way. Okay, every time we want to change the underlying dependencies, for example buns, okay, and we introduce those dependencies like that by declaring classes inside the main class, which is the chicken burger cost, right? We will risk introducing new bugs into this. So remember, not only there's this buns, when we make a new class called buns and then we want to test it, right? We hope that there's no bugs, but it's possible that the class buns has bugs in there, and then when you type it in here, you also introduce new bugs. So the question is, how do we change the underlying dependencies without introducing bugs into the chickenburger.cs class, right? That's the key focus of the video. Okay, how can we change the dependencies classes, okay, without changing the chicken burger class, right? So how can we change all the underlying dependencies without changing the chicken burger class? All right, so this is where the term injection comes in. Okay, the term injection comes in, right? So what's injection about? Okay, so over here you see that we actually declare a new object here, the petty object. Yeah, we declare the petty object right here. Okay, we declare the petty object right here, and what we need to do is what we need to do is, we need to have this petty object. Okay, the petty with a small p. Okay, we need a petty object, and then from that object we need to execute this cost function or cost method. Okay, and we need to repeat this 3 times with the buns and with the other things. Right, so instead of getting this petty cost over here, instead of declaring the object here, the idea of injection is to declare the object outside the class. Okay, so you don't declare the objects using the chicken burger class. You do it before. Okay, you do it before. Right, so you declare the petty object outside, and then you declare the buns object outside, and you declare the other object outside. We do it outside the chicken burger class, and then after that, once you declare the objects outside, you put it in the class as a function, okay, or as an argument, so to speak. Okay, so normally when we have functions, we have arguments like this. Maybe you have a double text rate, right? You can make something called double text rate. Okay, and this will actually make it necessary such that you give a text rate into this cost method or cost function, and then we can use this text rate here to calculate the cost that we need. Okay, so instead of putting giving this text rate as an input, all right, we will instead have we will use something else as an input. We will use this petty object as an input. So petty here will be an input into this petty cost. All right, so this is the type of the object, and this is the object itself. Okay, so the type of the object, okay, is the class name. So for example, you have petty as the class name, then you specify what's the variable, the object that you're putting in. So you're putting in the object as an argument into this class. So that's what injection is like. So let's show you how this is done in a more simple way, and then the more correct way. Okay, so this is injection fundamentals. Okay, so injection is literally you're injecting or putting in another class or another variable. Okay, so that's where the term injection comes from. You declare the object outside, and then you use it as an argument in these classes here. Right, so let's see how this is being done. Okay, so we have the class we have the classes here. So let me save and quit everything. Okay, let me save and quit everything. And let me check whether I have my chicken burger. Okay, I'm not putting in any new dependency injection just yet. So let's vim models star.cs and we go to pages, test page.cs html. We'll have both open, and then we use vsplit to split it into left and right screens. Okay, these are all the classes, and over here we will have our HTML code, and here is our chicken burger object. Okay, chicken burger object. Alright, so what are we supposed to do? Okay, so for dependency injection, we will need to create the outside things first, right? For injection, okay, so in a sense, what are we injecting here? We are injecting the dependencies. So the dependencies are the buns class or the mock buns class. Okay, the buns class or mock buns class, there's the mock other class or the other class, and then mock petty and the petty class. So we'll make objects for all of these, okay, so that it can illustrate a point. So for dependency injection, we declare all the objects first. Okay, of course this is not the way that developers will actually do dependency injection, but for the sake of displaying and making the concept a little bit easier to understand, I'll do it like this first, and then we'll do it using the more complicated way after that. Okay, so let's see. Okay, so let's do this. Okay, we have a mock patty class, and then we'll make a mock patty object equals to new mock patty. All right, and then what else? Patty equals to patty equals to new patty. All right, so this is declaring two objects right here. Okay. Then what else? Okay, let's do the buns class. Okay, mock buns equals new mock buns. Okay, I'm going to make objects of all the classes I'm making first. Okay, buns equals new buns. Okay, if you're only seeing the hearing the audio must be very strange, but okay, never mind. We'll have the other class as well. Mock other equals to, or mock other equals to new mock other. Okay, so I'm declaring 6 objects here. Okay, other equals to new other. Okay, so this is making all the objects first. Okay, I'm making all the objects of the mock patty, the mock buns, the buns, mock other, and other. So these are all the dependencies. Okay, so very good. Okay, now thing is, once we have these dependencies created as objects, we need a way to pass those objects into the chicken burger. Okay, the chicken burger needs a way of receiving those objects. Okay, so here we can do this. Public double inject. Okay, literally is this function exists or to inject things. Maybe instead of double, I'll use void, because well, double will require me to return a value called double. If I use the void, it means that I don't need to provide a return type. Okay, I don't need to use this return statement here. Okay, so this public void inject will be here. This public void inject will be here, and what is his job? His job is to take in all these objects, the patty, the buns, and the other object. Okay, so let's see, patty, buns, what's the one? Other. Okay, so remember, other is a class, and this becomes the type. Okay, the object type, just like text is a type of double, and then other variables you have to type them as a string, as an integer, or whatever. Okay, so the buns class is the type of this buns object. The patty class is the type of this patty object. Okay, so once we have this, we are able to then bring in our patty, our buns, and our other class. Okay, so this is how we do it. Okay, so okay, I will call this one inject real. Okay, so this is the real version of the class. And then how does it happen? Okay, usually when we have these things in, we will need to, well, let's say, yeah, the moment we have this patty, we have this object patty. All right, we will have it existing inside the function. But once the function finishes running, this petty object will be destroyed. It will be gone. Okay, that's how functions work. When the function finishes running, all the variables declared in the function or the method, it will be gone. All right. So, okay. So, since all the variables you declare as inputs into the function will be gone, we need a way of making it stay in the class. How do we do it? Okay, we can do it like so. We can say that we can make variables like this: private. Private. What do you call that? We'll call this petty. It's a petty. I will call this variable. Okay, this variable underscore petty. Usually, private variables, we do not want outside people, the user, to mess with these because these are important. They are dependencies, so we do not want to play around with them. Okay, but this petty will stay. Okay, this petty will stay as long as this class, this object is kind of active. So even if you finish this what do you call that? You finish this. You finish executing this function. You have somewhere to store this petty object. So I can store it under this private petty. We call it attribute. Okay, so we can store it under the private petty attribute. So remember, classes are a collection of functions or methods and variables. So these variables this is one example of us having both functions and variables in the same class. Okay, previously we were just using classes to help us collect together similar functions. Okay, so here we have the petty, and then we can actually assign this petty will be equal to the petty that we inject inside. Okay, so we can do the same for the buns as well. Private buns, okay, underscore buns, private other underscore other. Okay, so I'll just delete a few lines, and then we will keep doing it. Okay, buns equals to buns. Okay, that means we are setting this private property or private variable to be equal to the input that we put in here. So this is the way we change things inside our class. Okay, so the last one is other equals to other. Okay, so this is what we can do, and once we have the petty, buns, and other, okay, once we use the inject rail, we should be able to have petty, we should be able to have buns, and we should be able to have the other as objects that we injected into this class. All right. So what do we do here? Okay. So we do not need to declare the petty object anymore. We can just straight away use the petty cost like so. Okay, petty cost equals to this underscore petty cost. So first thing first, of course, we need to inject petty, buns, and other, and then this will actually change all of this into the objects or dependencies that we need. So once we have those objects, we can start using those functions within the object, like cost. So I'll just say this injects the real dependencies. This function injects the real dependencies. Okay, because they are the more complex version. All right. So this one will be just the buns, and this one will just be the other. Okay, let me undo this. Other. Okay, so if everything checks out, all we need to do to start this code is to make sure we do the injection first. Okay, so our chicken burger needs to be injected. Our chicken burger needs to have dependencies injected. So this is the step where I inject the dependencies. Chicken burger dot inject. Okay, what's the first thing? First thing we need is our petty object. So we'll put the petty object in. Okay, petty and then the next thing is buns, and the last thing is other. Okay, then we should, once we inject all these dependencies, so this is the injection step, dependency injection step, so this is what dependency injection is, we can then use our cost function. Okay, alright, let's see whether the thing's working. Oh, we have an internal server error. What happens? Object reference is not set to instance of an object. So let's check out the petty cost and see what happens. Okay, so remember, every time we change the code, we risk putting in new bugs into the system. Okay. Okay, so what is this? Let's check out where our thing is. Okay, it says the petty cost seems to be the problem. So let's take a look at the petty cost. Okay. Okay, so it's wondering where this petty cost is. All right. Okay, so what's going on here? All right, what's going on here? Okay, so you see when we declare this chicken burger object, right? When we declare this chicken burger object, okay, when we declare this burger object, we are going to use this we are going to have this inject real thing. We are going to have private petty, private buns, private other. Okay, and then we are going to have the double. We're going to have our cost function, our petty cost, our buns cost, and our others cost. Okay, sure, all this is good. Okay, the moment we start looking at this petty cost, okay, the C# reader is going to look at this line. Okay, double petty cost, okay, that's fine. I'm making a new variable. Then I need to look for this underscore petty dot cost. Okay, underscore petty dot cost. What's underscore petty? Now, underscore petty, we have not even defined what underscore petty is yet. Okay, so that's going to be a problem, because we don't know what underscore petty is until we use this inject real function. Okay, we don't know what is underscore petty until we have this inject real function. So somehow this inject function should be executed the moment we create the object. Alright, so what am I saying? Okay, the moment we ask C# to say, hey, can we execute this petty cost function? Okay, but over here C# doesn't even know what this petty is, because we have not made this petty object yet until we inject it into the function. Okay, so the only way to make sure that this error doesn't occur, because there's no object yet. Okay, we did not explicitly make a petty object inside this chicken burger class. We said that we need to make the object outside, and then we put it inside the chicken burger class using an injection function. Okay, so we don't have those objects readily available when we start the class, and then we say, okay, petty cost, we need a petty cost thing. Okay, we need a petty cost, and to have petty cost we need this petty object already existing within. But C# will say, hey, wait a minute, I don't have this underscore petty object defined yet, so that's why it's giving you the error. Okay, how do we solve this problem? Okay, we need the injection to occur the moment the object is created. Okay, all right, so yeah, okay, let me put it here. Injection must occur the moment the object is created. Okay, or let me put here dependency. Okay, dependency and injection must occur the moment the object is created, otherwise you will run into this sort of error over here. Now you see this object reference not set to instance of object, because you are trying C# is trying to execute this petty cost function, but it doesn't see this underscore petty being an object. It does not even exist. So the only way for C# to know, oh, the object is supposed to exist, okay, is that you must have this dependency injection occurring at the moment the object is created. So how do we do this? We will explain it in our next video. Okay, thank you for watching. I'll see you again.